Okay, so we're going to review percentiles and quartiles. A percentile is a value on a scale of 100 that indicates the percent of a distribution that is equal to or below it. So basically what we're doing is we're ranking data points on a data set from lowest to highest. So the lowest value is the first percentile, and the highest value is the 99th percentile. If we want to calculate this, we can use the formula n plus 1 times p. So n is the sample, and p is the desired percentile in decimal form. If you wanted to do this in Excel, you can use this function right here. So equals percentile parentheses array, which is the data set, and then k, which is the desired percentile in decimal form. So here's an example data set. We have 20 data points in this set. So if we wanted to find the 10th percentile, which is already given, we'd go n plus 1 times p. So 20 plus 1 times p, which will be 21 times 0.1, which will give us 2.1. So our 10th percentile will be positioned at the second data point. So it looks like our 10th percentile is going to be 1. And you can repeat this with any percentile and it should work. But note that this equation gives you the position of the percentile, not the actual value. Moving on to quartiles. So the definition for quartiles is 3 values that split sorted data into 4 parts, each with an equal number of observations. So what quartiles does is it gives us a dispersion of the data. So with the dispersion, here are our points or our quartiles. So we have Q0, which is the minimum, which is the lowest score in the data set. We have the first quartile, which is the 25th percentile. We have the second quartile, which is the median, or the 50th percentile. We have the third quartile, which is the 75th percentile, and the fourth quartile, and the last one, which is our maximum and the highest score in the data set. Another important value when speaking about quartiles is the interquartile range, the IQR, and is the range between the first quartile and the third quartile, calculated Q3 minus Q1, and that gives us the middle 50th percent of data in the data set. So the minimum, first quartile, median, third quartile, and maximum give us our 5-number summary. Methods to calculate quartiles manually are the same as percentiles, using that n plus 1 times percentile. And in Excel, you insert the function quartile, parentheses array, which is going to be your data set, and then quart, which is the desired quartile, entered in a number between 1 and 5. So 1 will be Q0, or your minimum, and then 2 will be Q1, 3 will be Q2, 4 will be Q3, and 5 will be Q4. Here's a diagram showing what how each quartile is represented in what is called a box and whisker plot. So starting from the left, we have our minimum value, so our lowest value. Then we move to the beginning of the box, which is going to be Q1, or the lower quartile, the median, and the upper quartile, or Q3. And then we're going to move to the end, and we have our maximum value. So we have our box in the middle and our whiskers on the end. And what the whiskers represent, so the whisker on the left represents the lower 25% of data, and the whisker on the right represents the upper 25% of the data. And then the Q1 to Q3, or interquartile range, represents the middle 50th percent of our data. And if you didn't know, the median represents the middle of our data. Now, the box and whisker plot may not always be symmetric, and this depends on the distribution of the data. So if we have symmetric data, it should look nice and evenly distributed. If our data skew to the left, you can see the median is going to be pushed to the right, and then you're going to have a longer left side of your box and whisker plot, and vice versa for the data that's skewed right. You're going to have our median pushed to the left and the rest of the box and whisker dragged to the right. And that's pretty much percentiles and quartiles again. Percentiles kind of represent position of our data set, and then quartiles add in a dispersion element of our data set. And here are my references.